We're going to look at the difference between an air-cooled chiller and a water-cooled chiller. We're going to look at the refrigerant circuit, how heat is moved around, how heat is rejected, and where you might locate an air-cooled chiller as opposed to a water-cooled chiller. The main purpose of the chiller, of course, is to remove heat from the occupied space. Heat comes in the way of people. People generate heat based on the activity level. Whether they're sitting, it's less than they're doing exercise. If they're doing exercise, it's going to be generating more heat. And then you got lights. The different kinds of lights produce different amount of heat. You got plug loads, which is anything that's plugged into the outlets like computers, any machinery. And then you have your solar load, which can be shining through the windows, or the conductance of the temperature difference between the outdoors and the indoors, and the resistance of that wall will give you a certain amount of heat gain. That's the heat we want to remove and bring that to the chiller so that we can cool down the space. I'm going to show you how a refrigerant circuit for a water-cooled chiller and an air-cooled chiller is somewhat similar to your home air conditioner. Here's a layout of your typical refrigerant circuit. And the four components that you'll find in just about every refrigeration system is you have the evaporator coil, and this one it's air-cooled. You see the fan. And on the other side you have the condenser coil, and it's air-cooled, as you see the fan blowing over the coil. And then you have the compressor, which moves the refrigerant around the system. And then you have the expansion valve or metering device that controls the amount of refrigerant that goes from the high side here in red to the low side in blue based on the demand required. Now, if we want to make this into an air-cooled chiller, then we need to get rid of the fan and bring in a heat exchanger, a shell and tube heat exchanger, and then we'll pipe water in and out of it, which will be cooled by the refrigerant. So now the refrigerant, instead of having air blow over the cold coil and blown into your room, now the refrigerant will cool water, and water will be taken to an air handler, which will then blow over a chilled water coil and cool the room. Now, this leaves us with the condenser side, which is air-cooled still. We still have a fan blowing the heat to the outside of the building. Now, if we want to make this a water-cooled chiller, we need to get rid of the fan and also bring in another shell and tube heat exchanger and pipe water in and out of it. So now, instead of the heat being thrown outdoors with a fan, now we're going to pipe in water, transfer the heat from the refrigerant to the water, and take that water and the heat with it to the cooling tower, where we'll reject the heat and bring back that cooler water and start the whole cycle over again. So all we've done here is gotten rid of the fans that were doing the work of the heat transferring, and now we're using heat exchangers. They exchange the heat from the refrigerant to the water, or from the water to the refrigerant. The refrigerant and the water never mix. In this case, the refrigerant is going on the outside of the tubes, and the water is going through the tubes. So remember, heat comes from people, plug loads, which is your computers or anything plugged into the wall or any equipment generating heat, lighting, and any solar. If you had windows here and the solar was coming through, or you have the outside air, heat on the other side of the wall coming through the wall through conductance, you have that heat generated in this space and you want to remove that. That's represented by this heat molecule here, and what will happen is we'll take that heat through the return air duct into the air handler and pass that heat into the chilled water system. And from there we take it into the chiller. And we'll continue on the next frame. Okay, now the heat has arrived from the chilled water. We've picked it up from the room. We brought it to the chiller, and that heat is going to cause the refrigerant, liquid refrigerant on the low side in the evaporator to evaporate. And it absorbs the heat. And then that heat is taken through the compressor and gets compressed to a high side vapor refrigerant, which passes this to the condenser and into the condenser water and into the tower and then out of the tower. And that's how we get rid of the heat from the building, from the chilled water circuit, through the refrigerant circuit in the chiller, to the condenser water circuit and out of the building. Now, of course, a water-cooled chiller is more sophisticated than your residential package unit or split system that you find at home, but they have the same four components: the evaporator, condenser, compressor, and expansion valve. As you see here, this water-cooled chiller has all four of those. And to identify the components, you can see that the evaporator is insulated. Oftentimes, the majority of the times, you're going to find insulation on the evaporator. That's to prevent heat from getting into the evaporator. And the condenser will be uninsulated. And then your compressor is going to be sitting a lot of times on top of the evaporator, not always, but in this case it is. And there's an elbow going into, from the compressor, into the top of the evaporator. And then at the bottom there, you'll see the expansion valve. Okay, now if we look at an air-cooled chiller, we can identify the same components. You can see your compressor, there's two of them, one here. It's got two circuits and one here. And then your evaporator, you can see the barrel in the back there. That's the evaporator. And here's the suction line coming off the compressor. So it's sucking from the evaporator into the compressor, through the hot gas discharge, into the air-cooled condenser. Now here's the coils for the condenser, and here's the fans on the top. And turning this, we can see that we're going to have some expansion valves over here before we go into the evaporator. So it's a dual circuit, meaning we got two separate circuits. One circuit here with this compressor and another circuit over here. And here's an expansion valve here, an expansion valve here for the separate circuits. So often you'll have a dual circuit to control capacity. And here's the coils. These are copper coils, most likely, aluminum fins. And the refrigerant runs through there. And then the air is sucked from the outdoors over the coil and blown the heat straight up and out. And this is located outdoors, but this is your air-cooled chiller. All right, so if we look at this, number one here is the refrigerant circuit. That's within the chiller. The chiller has the four main components: the expansion valve, the condenser, which is a heat exchanger, shell and tube. It's got a shell and it's got the tubes. 3, the compressor. And the fourth component, major component, is the evaporator, which is similar to the condenser. It's a shell and tube heat exchanger. Now the process begins by this low side liquid refrigerant coming in at a cooler temperature than this chilled water. So the heat is given to the refrigerant, causing it to go from a liquid to a vapor, causing it to evaporate. And that evaporated refrigerant inside this chiller goes into the suction side of the compressor, which compresses the refrigerant to a higher temperature, higher pressure vapor, gas, which then travels to the condenser, where the vapor is to be condensed, meaning it's going to turn back into a liquid by giving up its heat to the condenser water coming through the shell and tube heat exchanger. Now the refrigerant and the water never touch. they're separated by these tubes. The refrigerant then condenses, going back to a liquid, high side liquid, high pressure liquid, where it comes to this metering device, this expansion device, which meters the amount of refrigerant onto the low side based on the demand of the chiller. So it goes from high to low pressure liquid through this expansion valve. Okay, so the first thing we're going to do is give each floor an air handler, a chilled water air handler, which we're going to provide chilled water to. There can be one or more of these per floor, or there can be several on the roof. Somewhere you can put these air handlers. They can be indoors or outdoors. You can get waterproofed ones, weatherproof for outdoors. Now you got an air-cooled chiller. This has to be outdoors somewhere. So either on the ground floor, it can be on the low roof, it can be on the upper roof, but then you have to pipe it with chilled water to each one of those air handlers. Wherever you put them, you got to get the pipe there from that air-cooled chiller. So if you put that air-cooled chiller on the roof, then you got to pipe it from the roof. The good thing about putting it on the roof possibly is maybe it's out of sight if you don't have floor area or area on the ground level. Now, if you go to a water-cooled, you got the same air handlers, one on each floor, multiple on each floor, but then you have a water-cooled chiller. Now, this is not made for outdoors. The majority of these are indoors. You can get them made for outdoors, but that's very rare. The majority of the times, these are indoors. They're in the basement, they're on the first floor, can be on the roof. Wherever you put it, you still need to pump that water from the evaporator to the air handlers. But with water-cooled chillers, you got one more piece of equipment to worry about, and that is the cooling tower. So the cooling tower can be put on the ground level, or it can be put on the roof. But once again, you're going to have to pipe from the condenser side of the water-cooled chiller up to wherever you put that cooling tower. So you got to think about the routing of the piping of the condenser water. Now the condenser water majority of the time is not insulated, so you don't have that expense. But you got to remember, those cooling towers are big and heavy. The more tonnage you got, the more cells there are. These things can weigh 30,000 pounds more. So you got to have structural reinforcement if you're going to put that on the roof. So you can put it on the roof or you can put it on ground level. But those are some of the things to think about. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.